Ever puzzled over why an apple falls from a tree and doesn't fly off into the abyss above? Or why a football doesn't keep rolling once it's been kicked? That's because of a mysterious yet omnipresent force that shapes our world. Yes, folks, we're talking about energy. Today, we'll delve into the fascinating universe of kinetic, potential, and impact energy. So brace yourselves for an exciting journey of discovery. Who knows, you might finally crack why that football isn't invincible. Imagine you're a superhero. Your power, kinetic energy. But wait, what exactly is it? Kinetic energy, folks, is the energy of motion. If you've ever been late for a bus and had to run like a roadrunner, you've used kinetic energy. Now, if you had superhero powers, you could increase or decrease this energy at will. Picture this. You're at a standstill, about to miss your bus. You crank up your kinetic energy and whoosh, you're at the bus stop in a flash. Or you're running too fast, about to crash into a wall. You dial down your kinetic energy and stop just in time. Cool, right? But let's get scientific about it. The kinetic energy of an object is calculated using the formula 1/2 times the mass of the object times the square of its speed. Let's put it this way. If you're a superhero who weighs around 70 kilograms and you're sprinting at 5 meters per second, your kinetic energy would be roughly 875 joules. You could practically light up a light bulb for a few seconds with that energy. Imagine that. Now, you might have noticed that speed plays a significant role in the energy equation. The energy doesn't just increase as you go faster, it squares. So if you double your speed, your kinetic energy quadruples. If you triple your speed, your kinetic energy increases 9-fold. That's why when you're running late for class and you hit top speed, you feel like a superhero. But remember, superheroes have to use their powers wisely. If you ramp up your kinetic energy too much, you might end up crashing into something or someone. And well, that's a whole different kind of energy, which we'll get to later. So, with great power comes great responsibility, and with great speed comes, well, great kinetic energy. Remember that next time you're late for class and sprinting like a cheetah. Imagine you're on top of a hill with a sled. You feel the thrill, right? That's potential energy waiting to be unleashed. Picture this. It's a chilly winter day and you're bundled up standing at the peak of a snow-covered hill. In your hands, you hold the reins of a trusty sled. Your heart is pounding. Your breath is fogging up in the cold air, and the anticipation is building up inside you. That, my friends, is the perfect illustration of potential energy. Now, what's potential energy, you ask? In the simplest terms, it's the energy an object possesses due to its position or configuration. It's like the universe's way of saying, hey, this object is in a pretty cool spot. Let's give it some energy for that. Take our sledding scenario, for example. The sled at the top of the hill has a lot of potential energy. Why? Because it's high above the ground and gravity is acting on it. The higher the sled is, the more potential energy it has. This is because potential energy is directly proportional to the height of the object. But here's the fun part. Potential energy doesn't stay potential forever. It's like a coiled spring, ready to leap into action. The moment you push off from the top of the hill and start hurtling down, that potential energy transforms into kinetic energy, the energy of motion. But we'll save that discussion for another day. So to recap, potential energy is the energy an object has because of where it is or how it's arranged. It's influenced by factors like height and gravity. It's like that adrenaline rush you feel at the top of a roller coaster, looking down at the plummeting track below. It's the energy of possibility, of what could be. So, the potential energy is like that nagging reminder in your head that says, hey, you could slide down this hill at any moment. It's always there, just waiting for its moment to shine. Ever hit your toe on the edge of a table? Ouch! That's impact energy saying hello. Impact energy, also known as collision energy, is the energy produced when two objects collide. Remember that time you accidentally stubbed your toe against the table? Well, that was you experiencing impact energy firsthand, and it sure did leave an impression, didn't it? To understand impact energy, let's consider the two key players involved in the unfortunate toe table collision. First, we have your toe, which has a certain mass. Second, we have the immovable table, standing in the path of your unsuspecting foot. When your foot was swinging forward, it had a certain speed or velocity. The energy your foot carried due to its motion is the kinetic energy. And the moment your foot met the table edge, bam! That's when the kinetic energy transformed into impact energy. Now you might be thinking, why did it hurt so much? Well, it all comes down to the mass of your foot and its velocity. The more mass an object has and the faster it's moving, the more kinetic energy it possesses. And as your toe found out the hard way, more kinetic energy means more impact energy. So the faster your foot was moving and the more mass it had, the greater the impact energy and the louder your yelp of pain. But let's not forget the table. Its role in this collision is crucial. Despite being an inanimate object, it absorbed the impact energy from your foot, causing it to vibrate or move slightly. This is why sometimes, if you hit a table hard enough, you might even see it shake or hear it thump. So, impact energy, in a nutshell, is the energy that is released when two objects collide. It's a transformation of kinetic energy and is influenced by the mass and velocity of the colliding objects. So the next time you stub your toe, remember, it's not just an ouch, it's an interaction of mass, velocity, and a very unfortunate table edge. We've journeyed through the world of energy, from kinetic to potential to the toe-stubbing impact energy. Let's take a quick rewind and revisit the high points of our adventure. But remember, we're keeping it light and breezy. No heavy scientific jargon here. We kicked off our journey with kinetic energy, the energy of motion. Think of it as the energy that a sprinter harnesses when he bolts from the starting blocks. It's all about movement, speed, and direction, and it's a total thrill ride. Then we moved on to potential energy, the energy of position or stored energy. It's like a coiled spring just waiting to unleash its power. Imagine you're at the top of a roller coaster right before the big drop. That's potential energy, my friends. The calm before the storm. And finally, we arrived at impact energy, the energy of collision. It's the energy that's released when two objects collide. Remember the last time you stubbed your toe on the edge of a table? That's impact energy. And while it can be a bit painful, it's also incredibly powerful. But hey, let's not forget the fun we've had along the way. We've cracked jokes, we've laughed, and we've learned a ton about these three types of energy. It's been quite the ride, hasn't it? And while we've had our fun, we've also gained a deeper understanding of the world around us. Energy is everywhere. In every movement, every position, every collision. It's an integral part of our universe, and understanding it helps us appreciate the complexity and beauty of the world we live in. So, the next time you see an apple fall from a tree or kick a football, remember the fantastic world of energy at work, and always be aware of those pesky table edges. After all, energy is all around us, and it's up to us to recognize and appreciate it. Ekaep site ekilent nokre, omrof scribe binus dinag nikiliders nosis elp video is added or join you. Fi until our next energy-filled adventure. Stay curious, stay excited, and keep exploring the fascinating world of energy.